So the title of module 2 is requirement engineering, and from the diagram itself, you can able to understand. Some customers they will express their requirements, but it cannot be understand correctly by the developer. So that's a mistake. For example, they want okay, so this kind of swing, but finally they have placed a sofa over here, and it's hanging. Sometimes they want constructing a bridge or something like this, maybe for playing. Okay, just a play area when they construct. But they or somebody may cut or remove something from there, and they may do some other modification, or this is how they'll construct the swing. Okay, but actually, what is the expectation of the customer? Okay, this is how the customer want, but they may do like this or this. So that's a mistake of people while they didn't understand the requirements properly. So now we are going to see here why requirement collection is needed and what are the different ways through which we can do this requirement collection. So this is called as a requirement engineering process. Okay. Uh, so, what is the benefit of this kind of a requirement in, gathering part when you do? So, it improves the stakeholders' satisfaction. That is, customer maybe happily be there throughout the process or throughout the construction of the project. Also, it increases the project success rate and it reduces the project cost also. Because once again, if you work on a particular project again and again, it saves the time. So that can be minimized. Wasting time and wasting resources, materials, manpower, all those things can be minimized while you understood the requirements part correctly. So that is why this is the benefit of while you understand or gather this requirement analysis part in the beginning. So this can be conducted with the help of asking so many questions and interactions with the customers, and you can listen to the customers and their emotions and their feedback, and finally you have to prepare the agreement. So the agreement part, you have to tell them, okay, actually, is this your requirement? When they say yes, okay, you have to finally go for an agreement or a plan. So this final agreement is a kind of a document that is called as SRS, Software Requirement Specification Document, which consists of the entire specifications which are required or deals with a particular project. So, what are the techniques that you will follow? Like I have told, questionnaire based interactions, or we can give some discussions on some scenarios, and then you can do discussion, and you can brainstorm, and then from that you can derive the scenario or the requirements properly, or you can build a small prototype or a model and you can show them. For example, a customer want to run a business, okay, that is okay, through a spin wheel based concept. When the customers come for purchase, okay, with the help of the spin wheel, they are okay, they are attracted by means of gift or receiving a gift. When this is automized, so when they say about, okay, spin wheel concept, there are some protocols and rules will be there, and at the same time it must be a profit and for the particular company also, or particular textile or whichever shops when they install such kind of options with them. When you do a purchase, okay, or the spin wheel also, through the spin wheel, when you get a card or a token when you purchase, okay, you will be connected with gifts. But how this is a profit for the customers as well as from at the end of a business person who run this product in their place. So such kind of discussion comes, you have to go through all kind of scenarios and you have to develop the application by writing different rules and protocols to satisfy both the end, that is the customer's end as well as the person at the shop which is connected. So you have to collect the requirements properly. So that is called requirement engineering. So what is meant by requirement engineering? It's a process used to discover and analyze and validate the system requirements. So once you have listed out all these are your requirements, right? So that should be validated with your customer end also. The customer should understand and they should say, Okay, yes, this is how my house is supposed to be constructed. My house is supposed to be painted. This is how I'm expecting. So when it is sanctioned, okay, the same color, same model, and same features you have to apply for constructing a house. Similarly, software also. The static pages you can design, and you can just okay. So when they are happy with a button design or a text design or the font style, colors, everything you have to verify. And this is how in the beginning itself they may say, I want everything in 2D design or 3D design. My app design must contains the wheel is a 2D or a 3D wheel. Okay, so likewise they can say, and the colors, multicolors, or some one or two colors, or what type of font and style throughout the, okay, so everything is through voice or a text or okay, what type of interest, so everything you have to collect. So that what is called requirement engineering. So this project requirements falls under different type of. There are so many type of requirements will be there. So user requirements. So from the user, okay, so you have to identify as in it is a application user perspective. What are the ways of interaction going to happen? The user can only apply. They cannot do any other modifications or manipulations. And you can order. That is the way they have defined it. Means okay, the user can raise the order, or they can go for purchase only. Because suppliers can supply the product. They cannot buy. Okay, so such kind of or they cannot do modification. Who will introduce the discount? The owner of the particular website or particular business. They can announce only the discount. Okay, so if they announce for different products, different discount or same discount percentage, so just through some dashboard design they can select. Okay, so this is how different user perspective, what type of design is required, and through that they can fulfill their. So those things you have to collect, and that is comes under user requirement. What is functional requirement? How the application should behave while you click, what are the major operations it should perform. So registration, and what is the order also. So registration, then it is followed by, okay, something will go under waiting, or for example, sometimes the product is not okay, available, it is out of stock. Even though product is out of stock, the user can raise a request for demanding that product, and that can be later on purchased. So later on, the product can be okay. They can pay. Then don't talk. So this is how functional requirements are supposed to be identified. System requirements, that is the hardware and the software aspect you have to, which operating system, which platform, and what about the security aspect and ethical aspect. Okay, all those things you have to consider, and you have to work on this particular project. So that requirements also you have to focus on. And user interface requirements. So user interface requirements in the sense, the interface design is supposed to be flexible and more interactive. Listen the class. And the workflow. Uh, what is the first step? What's the next step? So likewise, you have to define the workflow or the process. And change management. In case of okay, for example, change management aspect, when you consider okay, so discount is a so discount is a particular change which is frequently going to be introduced in a particular product. Based on that, the price should go down, and but at the same time, it should bring up profit. So margin level will be set, and that, so that is a kind of a change. Or introducing some new modules. So that is also you have to identify, and maybe first version with this features, next version also. After once it is released, okay, they should give immediate changes under change requirement. The other team may work on it for continuous monitoring and release. Risk management. So under this risk category, Dawson, Dawson, you will be removed. So this is how you have to do, all these comes under the process of requirement engineering. So the next one is requirement engineering process. So one by one step, the requirement engineering also will go through. So these are the steps which are connected with requirement engineering. Okay, the first step is feasibility study. For example, the organization is coming for a discussion with the stakeholder, and they are proposing some project, and they have to do an analysis now that from the organizational perspective. When this product is released, whether it will be useful for the market or already such kind of product is available, and then what kind of changes that we have to bring it out so that our product will reach the market. For example, comparing with, there are different versions of phones and televisions, okay, that are produced by different companies, but they are adding more additional features and finding out the problems in the existing one. So such kind of analysis when they are doing, and this product is affordable, and when it is okay, so as per the budget, when it is produced, when it is marketed, whether it is a profit one or what type of problem it may affect the production process. So do we have the sufficient quantity of items for producing such kind of models, and so such kind of products. So all those things in the beginning. So how many orders we have to raise for buying the such kind of hardware component in case anything to be manufactured, so that in the market for a continuous release we can stay for a long time in producing. For example, some of the car companies, they are stopping their release of certain versions of car because when they face a certain kind of problem, or comparing with the older version, the newer models when it is released with a lot of additional features and upgradation, maybe that may brings a huge profit compared to manufacturing till the or continuing on the same old product. So such kind of study when you have to do, that is called feasibility study, and that is supposed to be documented. So that is comes under feasibility report. So this is how the first phase you have to complete. Any new plans, any new model, okay, you're targeting on in the beginning, that should be compared with the market scenario, manufacturing aspect, and everything. You have to check and verify whether my product may stand in the market for a long time or not. If it is a shorter period only people may use it, means within the particular period shall I able to gain such kind of profit, what I have expected. So such analysis you have to do during the feasibility study part. And then you have to start analyzing the requirements, okay, one by one. So you can communicate with the different stakeholders for the suppliers, or you can distribute to the third party agencies. Sometimes the entire software you may not able to produce, right? The software is hardware dependent or a software, okay, so such kind of aspect, okay, what is the software requirement, hardware requirements, and you have to approach such kind of agencies, and you have to distribute the work and start this communication, and you have to focus on designing the model. And so user aspect you have to work, system aspect you have to work, and then finally you have to validate what you have identified in the beginning. So everything is supposed to be documented at each different each phases. So that is called requirement engineering process. Okay, as I have told, feasibility study, what you are proposing, you just verify with the market scenario, and with the manufacturer aspect as well as the user aspect. When we produce this kind of a product, whether it is beneficial to the organization as well as to the customer, it may exist in for a long time, and do we have a sufficient budget to produce such kind of project or a product. Okay, so that is called feasibility study. So feasibility study decides whether or not the proposed system is, do we have to continue the project or do we have to stop the idea or a project. So that is done with the help of feasibility study. So this study focus on checking the system contribution to the organizational objective, whether it is whether it falls within the objective of the organization. That also should be verified, and whether the current technology and the budget are sufficient. Do we have a sufficient team with such kind of technology? Okay, so those things are verified with the under the time of doing the feasibility study. Then the after conducting the feasibility study, you can go and implement. the project. So at the time you have to start doing lot of collection of informations and one by one step, and you have to collect and you have to write the scenarios and you have to go for implementation. So that is how the feasibility study, what you have done, step by step approach you have to implement. Okay. So what is the next approach after conducting the feasibility study? That is called inception. So once the problem is understood, you have to go and discuss one by one scenario, and for each scenario, what is the solution. So that is going to be derived, and which is under the part of a waterfall model or some other model you can relate. So it is a preliminary communication model, and collaboration between it is going to happen between the customer and the developer. Okay, this project is finalized. So what next? We have to start collecting one by one requirements. So we have to raise the order with, or you can raise the tender with different people on purchasing different hardware component and the software components, building part. Even you cannot build everything together. Some part or some portions, okay, you can connect it with the third party agency, signing with agreements, ask them distribute the work, and they can also part of this communication. So that communication is discussions are going to happen during the time of inception. Okay, the first phase is called inception. The second phase is called elicitation. So elicit the requirements from all the stakeholders. All the stakeholders' point of view, you have to express what is the major requirements. Elaboration. Okay, so in detail, you identify, collect the data, and identify the functional and the non-functional behavior of the entire system. Okay, clearly you just identify it. Negotiation. Sometimes some deliverables are realistic and maybe not realistic. So those kind of discussions, arguments used to happen. So that with the help of doing such kind of brainstorming part, you can come up with some solutions. So all these are supposed to happen. For example, if you want to construct a house, you have to plan the house, and then you can identify how many floors are there, and what about the roof material. Okay, so in and out every detail. Based on that, you will come up with the budget, whether the budget is affordable or not. In case if it is not affordable, then we have to cut down certain things, and main things we have to focus on, and we have to work towards it. When the house is planned, okay, then we have to discuss with one by one material buying part. You have to raise the order. Also, who is the man? Okay, so that discussions are going to happen with different sellers, as well as the people who involved in the, maybe carpenter, painter, okay, the mason, likewise. So different kind of people are going to involve, so you have to have discussion with, and you have to get the approval from them also within that affordable. So such kind of negotiations are going to happen. And then only if it is a robotic based project, when you do, okay, so this is your plan, the plan is derived, okay, go for buying components. And buying components, okay, if you are a huge producer, you are targeting more audience, more customers, and you want to reach to a huge market, and not only in a particular country, all over the world, means, okay, so you have to focus on. So tenders will be raised and orders will be given, and you have to purchase, and then only you have to assemble, and then you have to do the testing and implement. So all these discussions and communications going to happen during the time of these phases. And then specification also. So specification means everything is supposed to be documented, and mathematical analysis also you have to do. Finally, you have to validate what you have discussed, whether it is possible, okay, whether it is reached, okay, get an agreement, okay, this supplier is supplying this, agreed. Then only you have to go for, after this requirement collection phase, then only you can go for implementation. So do a thorough analysis with the help of moving from all these phases. So the first phase is inception, second one is elicitation, third is elaboration, fourth is negotiation, and the fifth phase is specification, sixth, seventh phase. Finally, you have to manage and control everything. So these are the seven phases, seven major phases in requirement engineering. Okay, so all these are discussed in detail here. Okay, so you can go down, you can go and do a reading part of these seven phases only. Okay, so how to build the analysis model? What you have analysis, how you can show it better to the other people, and you can start explaining. Maybe an architectural diagram you can draw. If it is a blueprint, okay, the construction of a house, they can understand. And if it is an engineering drawing diagram, okay, the mechanical people can understand, and they can start designing some wheels or cars or any screws or whatever part of a hardware, okay, they can able to understand. What about the software? So software view, how we can give the top down view of a software, bottom down, so it is not possible, right? So here everything is classes, and so you're going to write the class based programs, and you're going to okay, design the behavior of each classes and what is the data flow. So that is why it falls under these four categories: scenario based element, class based element, behavioral element. So with the help of UML diagram, unified modeling language diagrams, you can draw different diagrams and you can express, okay, this is how my software is going to work. Okay, so the first diagram we are going to learn here is use case diagram. So what is meant by use case diagram? So this diagram, okay, the definition, okay, this is the definition. So a collection of user scenarios describe a thread of usage of a system, and each scenario is described from the perspective of an actor. So here in this UML diagram, the first basic diagram is called use case diagram. And people are using a star UML, it's an open source version, or a rational rose, that is a license based version. So with the help of these two, like engineering drawing, we are using CAD, right? So CAD software, with the help of it, they are drawing. As a software designer, you have to use these any one tool, okay, Star UML or Rational Row software, and then you can say, and you can diagrammatically express how the software is working. Okay, so the first basic diagram is use case diagram. It just shows an interaction which is going to take place between the user and the system. So user and the system means, for example, EduServe application, there are different users are there: student, staff, HOD, okay, different hierarchy, people, finance, so hostel side, so many HODs, and okay, till the top level hierarchy, so many. They are all called as actors. When they interact, when they log in inside the system, what are the things they can access and what is the behavior of each and every module, that you are going to diagrammatically present. That is called UML diagram. And use case diagram gives the overall view of the entire project. And that is with the help of use case diagram. So use case diagram consists of three main components, that is actor, use case, and system bound. This is the shape of an actor actually. Okay, a circle, horizontal line and a vertical line, and it is split it in two. Okay, again two lines, like an arrow mark. So this is the shape of an actor. Okay, and below this shape you have to type what is the name of actor. Name must start with an uppercase. Okay, the first one, first letter must start with an uppercase, and the name must be a singular. It is not supposed to be a plural one. What is use case? Okay, use case means the task which is performed by an actor. For example, login, okay, that is one of the tasks. Registration, that is one of the tasks performed by this actor. When they click, what are the actions will be performed, that will go down. Okay, so the main use cases are, what are the actor can as a student, what are the activities you can do in EduServe? You can view the attendance. Okay, that is one use case. You can view class attendance, assembly attendance, and you can view your internal marks, and you can view your semester marks. You can view your subject wise attendance. Okay, you can view your hourly wise attendance. So likewise, a lot of things are happening now. So one by one, small, it is represented in a oval shape. Okay, what is system boundary? Within the system only you are going to place all these use cases inside the system bound. Okay, so inside the system name is EduServe. You can name it as EduServe. Maybe EduServe is connected with another system, means okay, that system you have to connect. Even that software is connected with another one different software. Okay, so this is how, what is the system, whether it is a single system or multiple systems are connected. So that system name you have to mention it here. So this is how, these are the three main components connected with use cases. So what are the relationships through which, okay, relationship means the lines you're going to draw and you're going to connect and use it with the use cases. The simple basic one is association. It's a solid line. Okay, You have to, this line doesn't have an arrow mark. That means it is bidirectional. Okay. And if it is a unidirectional, you can mention the arrow mark. Always a user must be connected with an use case with the help of an association symbol. It just represents there is an interaction between this actor and this use case. So, for example, bank application, a customer can do what? They can transfer the fund. That is one of the tasks, right? So, this is how an example is given. What are the other type of relationships? Okay, for example, when they do okay, so here when you social media post, when you connect two use cases, that time you should not use association. Instead, you have to use the dependency symbol. The dependency symbol is a dotted arrow. Okay, dotted arrow. The direction you can mention whether this use case depend on this use case or this use case depend on this use case. Likewise, the directions you have to mention. There are two type of dependencies are there, that is called include, another one is extend. What extends? Okay, for example, this is called extend and this is called include. So what is meant by, there is a difference between these two. Okay, that is very, very important. And use case includes another use case, that is very simple, dash, and it represents a modular and reusable design. For example, compose to post. When you post, okay, it may be an image. Okay, that is why in when you draw this diagram, when it is given to the development team, when they look at it, okay, they'll develop one by one component, and they will Facebook application. When you post, at the time itself, lot of small icons are coming, right? So you can attach an image, you can attach you can place a text, you can attach a video, or you can tag some people. You can attach so many things. So all those things it includes, but this is an optional one. Optional one. Any one is mandatory, but all other things are optional. So it may or may not, but it is not mandatory. Okay. So this is how such kind of use case connect depends on another use case. Okay. So you have to mention it with the help of include relationship. Okay. What is the extend relationship? So it is mandatory. For example, if you book a flight ticket, definitely you must select at least one seat. So this is depend. Okay, it is connected with another use case, but it is a mandatory one. So use case can be extended with another use case, but okay, maybe some, okay, mostly it may not be. It is for handling optional or exceptional, but mostly we never use for optional. Okay, but it is in a mandatory content. Okay, so at the time we'll go for this, that is extent. Some use cases may be derived from another use case, right? For example, you can consider this is generalization relationship. It is always faced towards the parent, and these are two childs. Okay, for example, rent vehicle may be different types of vehicles. User may go for booking this vehicle or this vehicle or this vehicle. Vehicle means common features will be there, but maybe price or some other details may vary, but price is a component which is current. So this is comes under the category of generalization. So most of the features are same, which is similar to the parent. So such kind of use cases are connected with the help of generalization. So that is a arrow mark. Okay, it's a triangle shape, and always it must face towards the parent. Okay, the child nodes you can connect. So this is how in a use case diagram you can mention some of the generalization relationship. So overall diagram you can draw like this. Okay, so this is the system. Inside the system you can name it. Here some mistakes may be there. Please, okay. So you can consider. So all the primary actors you just keep it in the left side, and the secondary actors you can. Primary actor means who plays a major role. So for example, EduServe is a system, that is a okay secondary role. So EduServe system, who are all can be an actor. Actor may be a person or a place or a device. For example, ATM machine is a library, is a place, library, that is an actor. ATM machine is an actor, and hospital is an actor. Okay, that means that the database which is connected with the hospital, it means that. Okay, the person, a system, databases, all those things can be, but you keep all those things in the right hand side. Left hand side, the primary users. EduServe application means all the users will come to the left side. EduServe system alone will be there in the right hand side. And if it is connected with bank, okay, that also comes to the right hand side. And keep all the use cases in the center, and you can start connecting it. Okay, but avoid crossing lines like this. Okay, And here only association symbols are used. In cases if there is a dependency which is exists between these two use cases, whether it is includes or extends. Includes means sometimes whether it is mandatory or not. Okay, you just decide that use case and connect with the extends and includes. Go through the definition once again. So this is how you have to. This is an example for an ATM, a bank ATM applications. Okay, so bank is connected, ATM machine. Okay, so this is an ATM machine. When you do everything, all the transactions are going through the bank server, right? And so this is how different actors will be there. Normally, okay, customers, and followed by what are the other type of factors you have to connect. Okay, you should not bend the line. You have to draw the line straight. And different colors you can choose. For example, all the interactions with the through the customers, okay, you can highlight in one color, another color you can pick it for technician. So this is how you have to draw. This is a very simple diagram, one or two user perspective. If it is an editor application, definitely it will go at least 2 to 3 pages, right? So you can break down the architecture, you can start the diagram. One user perspective you can draw one use case, another user perspective, another diagram. Likewise, you have to draw multiple use case diagrams also for a big project. The next diagram followed by use case diagram is class diagram. That is, what are the use cases are there, and all those things are going to be converted in. Okay, it just represents the implementation aspect. So class diagram, class can be represented with the help of a rectangular symbol with three partitions. The first partitions represent class name. Class name should be singular and begins with uppercase. Okay, and the second part is called attribute. You have to write it in small. Okay, and if it is a second word comes, it is supposed to be big, right? Each word first letter should be caps except the first one. So also you can mention plus, minus, and hash symbol. Okay, so public, private, and protected. Public means okay, so minus, plus, and hash denote okay, plus denotes public. Okay, private is minus, and hash denotes protected. So these kind of attributes and operations you can mention. What type of return type, that is followed by colon. What type of data type, that is followed by colon, followed by the data type also you can mention. So this is useful for when you draw the diagram like this, no? For example, when you draw the entire project or a module, or for a particular module, when you draw a diagram, the developer can pick, okay, identify how many classes he is supposed to create based on this six classes he has supposed to create. What's the structure of each class? This class contains only one variable, one function, and which class is supposed to be connected with another class, what type of relationship, whether it is a generalization, whether it is a dependency, whether it is an association, and how many object of interactions are going to happen, whether it is one to one or one to many. That is called cardinality. Okay, so the traversal you have to mention how many times of interaction a person can book, how many tickets. Okay, so train passenger, right? So a train can have how many a passenger, n number of passengers. The n also, if you know, okay, you have to mention the start value is 1, the end value is what is the number you have to mention. Sometimes in between a person and an account, okay, how many accounts he can have. This is how you have to draw the class diagram. Okay, and the symbols and the relationship present in the class diagram is given. Okay, so these are the relationships. For example, composition, association, generalization, aggregation, association, dependency, and realization. So these are the notations you can use. Association, okay, it is bidirectional or it may be unidirectional. You can mention based on the interaction. Only request can be given. No, response also received means. Okay, you have to say association. And the next one is aggregation. Aggregation means the symbol for aggregation is a hollow diamond symbol. But aggregation is called as a whole part relationship. It denotes a stronger relationship with one class contains another class. So such kind of a situation. So which is the most important class here? Which is the least important class here? You have to identify. A company cannot function without an employee. So this class must be, a car cannot have okay, run without an engine. So car and engine, company and employee, student and college, bank and customer. Okay, so all these are connected with aggregation. The next, this is called as whole pod relationship. Composition is just opposite. It's a filled one with the same shape, diamond shape. Okay, it is called a pod relationship. Okay, it is called as a pod. Okay, for example, contact book. Okay, so contact and contact book. So if the book, contact book is deleted, okay, still the contact entries or associated contact entries also removed. For example, composition kind of application. When okay, so this is a whole container, this is part of it. One is removed, okay, even okay, some other options may be there, through that also it can able to function. Pond and crane, when you take, if the crane is not there also pond exists. Okay, so this is how composition relationship is a stronger form of an aggregation. So more stronger, okay, which is more significant, you can identify from this. Okay, so generalization, it is called as inheritance relationship. Parent class, subclass relationships comes. Okay, all major repeated variables and methods, you push it to the parent class. Remaining things you keep it in the child class. Okay, so that's all about class diagram and use case realization. When there is a concept of interface and replacing the generalization part. Okay, so at times you can use this interface concept with the help of realization. Means generalization symbol is ends with the triangle hollow, but the line was solid over there, but it is dotted. That represents realization. So you can see the notation during your exam. They'll ask you to pick shapes. So you should know what is the shape of composition, what is the shape of this, what is the definition, and some examples also. So they may say in between these two, what type of relationships are possible based on scenario. So that remaining things. Okay, so that's all about the second unit. So second, the module is about requirement engineering. So you have to know what is requirement engineering process and the benefits and feasibility study. And there are 7 phases in requirement engineering. That thing you have to know. Then what is use case diagram and what are the components present in use case diagram. The shapes you should know. It's a oval shape. Okay, and the system boundary is in rectangle shape, and what type of relationship and the relationships how to write. Extends mean it's a dependency. Dotted arrow denotes dependency over the two angle brackets. In between that, in small case you have to write extend, in small case you have to write include. So all relationships where you can apply, where you should not apply. And so relationships connected with use case diagram. Similarly, purpose of class diagram and the structure of a class and what are the relationship and when to use. So please go through this examples as well. So that's all about module 2. I hope you all have understood.